this is Mrs. Nearing, and I'm going to be talking about four main types of titrations that you might run into. Type 1, strong acid plus strong base. So this is your net ionic equation that's happening, no matter what the acid and base are. It's H plus and OH minus makes H2O, so you're making water. As you look at your graph, you're going to start out with a low pH because you're starting with a strong acid. You're going to add base to it. The pH at first is going to remain relatively steady, and it will jump up drastically when you are getting close to the equivalence point. The equivalence point is the middle of this vertical region, and that's the point where you've had an equal number of moles of base as you had acid to begin with. So at equivalence, all of your H plus has reacted with OH minus, and you're left with pure water. So you should notice the equivalence point in this type of titration is right at 7. If you are titrating a weak acid with a strong base, the net ionic equation looks a little bit like this. HA plus OH minus leaves behind A minus and H2O. Notice I don't split apart the HA here because it is a weak acid, and weak acids, only a little bit of them dissociate. So I'll leave the HA stuck together in my net ionic equation. I'm going to start with again, a relatively low pH because I'm starting with an acid. As the pH rises over time, when I hit this vertical region near my equivalence point, the pH is going to be above 7 at equivalence. And that's because when I titrate a weak acid, what you're going to be left with is a weak base. So this A minus ion is going to be basic. So this solution at equivalence will have a pH above 7. If I look at a strong base and a strong acid, it's very similar to this first graph we looked at, just the inverse. It's just flipped over. So I'm starting with a base, so my pH is high, and it is going to drop over time. And notice again, if I look at my equivalence point, which is roughly, the middle of that vertical region, the pH at equivalence should be 7. And that's because I'm adding hydrogen ions to my hydroxide. We're making pure water here. So at equivalence, it will be 7. As you add excess acid, the pH will drop and become low. With a weak base and a strong acid, again, I'm starting with a high pH, and as I add acid, at first the pH won't change very much. Remember, this is what we call the buffer zone. So at this point, I've got some of my weak base and the conjugate acid present at the same time. Same thing is happening over here, right in this region. I've got both weak acid and the conjugate base present. So this is forming a good buffer. So notice my pH is not changing very much here. But once I go past this buffer zone and I hit the equivalence point, that's when I've added equal number of moles of acid as I had moles of base. Notice all of my base will turn into HA, the conjugate acid. So my pH at equivalence will be below 7. So weak acid has a pH at equivalence above 7. Weak base has a pH at equivalence below 7. If it's strong acid, strong base, the pH will be at 7 at equivalence.